This video is on arithmetic series. A series is the sum of the terms of a sequence. A finite series has a first term and a last term, while an infinite series continues without end. An arithmetic series is a series whose terms form an arithmetic sequence. The formula for the sum of a finite arithmetic series is S sub n equals n over 2 times the quantity a sub 1 plus a sub n, where a sub 1 is the first term, a sub n is the nth term, and n is the number of terms. So for example, if I want to find the sum of the first 10 terms of a sequence, a sub 1 is going to be the first, a sub n would be the 10th term, and 10 would be the number of terms, my n value. Let's take a look at a couple examples here. We need to find the sum of each finite arithmetic series. So recall that we're going to use the formula S sub n equals n over 2 times a sub 1 plus a sub n. So I need to know the first term, the last term, and the number of terms. So for this one, a sub 1 is negative 40, a sub n is negative 10, but I don't know how many terms are in here. I guess I could go ahead and continue writing it out, but let's use the formula that we used in an earlier video. A sub n equals a sub 1 plus n minus 1 times d. Because I do know what the nth term is, I know what the first term is, oops, 40. I don't know what n is, and I know that d, my common difference, is going to be 4, because notice every time I'm adding 4. So I can use this to find n. So negative 4 equals negative 40 plus 4n minus 4. Negative 4 equals negative 44 plus 4n, adding 44 to both sides. 40 equals 4n, or n is equal to 10. Now I can use my formula. So the sum of the first 10 terms in this sequence is equal to 10 over 2 times negative 40 minus 4, or 5 times negative 44, or s sub 10 is equal to negative 220. So if I were to add up all of these numbers, negative 40, negative 36, negative 32, and so on up to negative 4, it would add up to negative 220. So our second example, a sub 1 is equal to 3, so that's good. So I need that value, and I have that. I don't know what a sub n is. I'm going to need to find that. And I know that n is equal to 10, but I also have information that d is equal to 5. So I can use that to find a sub n. So a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is equal to 3 plus 9 times 5. 9 times 5 is 45 plus 3, so a sub n is equal to 48. And now I can use my formula to find the 10th term, or the sum of the first 10 terms is going to be 10 over 2 times my first term plus my last term, or s sub 10 is going to be equal to 255. Okay. Let's take a look at a third example here. A sub n is 105, n is 15, d is 7, but I don't know what a sub 1 is, and I need that to use my formula. So I will use the formula from the sequences video. A sub n is equal to a sub 1, which I'm trying to find, plus n minus 1 times d, or 105 is equal to a sub 1 plus 98, or a sub 1 is equal to 7. So the sum of the first 15, because n is 15, terms is 15 over 2 times my first term, which I found to be 7, plus my last term, And simplifying that, S sub 15 is 840. And my last example here, I have a sub 1, a sub n, and d, but I don't know what n is. I don't know how many terms are in this sequence, but I can figure that out. So a sub n equals a sub 1 plus n minus 1 times 6, or 49 is equal to negative 23 plus 6n minus 6, negative 29 plus 6n, or 78 equals 6n, or n equals 13. So the sum of the first 13 terms of this sequence is 13 over 2 times my first term plus my last term, or the sum of this is 169. So those 4 examples were all a little bit different. They all were missing a certain piece of information. I showed you how to find that piece of information so you can use the formula. Now, one additional thing we want to take a look at is another way to write a sum, and that's called summation notation. It uses the Greek capital letter sigma, which is an S, and it looks like this, and that's used to indicate a sum. I know you've probably seen this in popular culture used to represent an E, but it's actually an S, a capital S in Greek. And this is called summation notation. So for example, the series 3 to the 3 squared plus 4 squared plus 5 squared, so on, up to 108 squared can be written like this. Notice that this out in front is the formula. The number on the bottom indicates the first value of k. You'll notice that it was 3. The number on top indicates the last value of k, which was 108. This is the explicit formula that's out front. And the number of terms, which is n, is equal to the last value of k minus the first value of k plus 1. And this deals with counting. So how many numbers are there between 3 and 108? I need to do 108 minus 3 and add 1. Because if I just do the subtraction, I'm not taking into account either the 3 or the 108. Let's do an example of this. So we need to find the sum of the finite arithmetic series represented by this notation here. So I have k starts at 3, and in other words, my values of k are going to be 3, and then 4, and then 5, and then 6, and all the way up till k is equal to 10. And this is my formula, explicit formula. I'm going to use 3k minus 4. So in order to find my first term, a sub 1, I'm going to plug in 3 for k. So 3 times my first value of k, which is 3, minus 4 is 9 minus 4, which is 5. So a sub 1, the first term in this sequence, is going to be 5. To find my nth term, my last term, I'm going to plug in the number on top, 10. So 3 times 10 minus 4, so 30 minus 4, or 26. So that my last term is going to be 26. Now, to find the number of terms, I'm going to do my top number minus my bottom number plus 1, or there are 8 numbers in this. And let's think about that. So if I'm going to use 3, 4, 5, 6, 7, 8, 9, 10, counting that out on my fingers, that's actually 8 different numbers. So I need to do the top number minus the bottom number plus 1. Now, why did I write a 7 there? It should be plus 1. Okay? So now I can use my formula. S sub n, or in this case I know it's going to be 8, is equal to n over 2 times a sub 1 plus a sub n. So basically what I'm using this notation for is to find out what is my first term, what is my last term, and then how many terms are there. So S sub 8 is going to be equal to 4 times 31, or 124. So in this video we took a look at an arithmetic series, and that is basically adding up all of the terms of an arithmetic sequence, the formula we use to do that, and what sigma notation looks like and how to find the sum of a finite arithmetic series given the information in sigma notation.